Okay, so today we're going to be working on 3-3C, absolute max, and mins on the open and infinite intervals. So basically our goal for today is to find out procedures to find absolute maxes and absolute mins on a closed interval. And also don't spill your coffee everywhere. You can ask why. Okay, so the first thing that I want to talk about is how do I find an absolute extrema in 3 simple steps. Step number 1. You need to find all critical points. So what that means, a critical point is either where the derivative is equal to 0 or where the derivative does not exist. So those are 2 places where the derivative either does not exist or is equal to 0. That's a critical value or critical point. Number 2, you're going to list all of the critical points and endpoints, that's very important, on a table. So very important here, endpoints count too. Last thing you're going to do is you're going to evaluate the function at all of the points and then pick the biggest one or the smallest one depending on what you're looking for. All right, let's keep on going. Let's go and practice. So the first thing that we did as a group is we talked about, hey, if I am just given this graph here, how can I find the maxes and mins? So this graph that was given, we didn't have an equation for it. We just want to find the max and mins on it. Specifically, we want to find the absolute maxes and the absolute mins. So absolute maxes are the absolute highest and absolute mins are the absolute lowest on a closed interval. Well, the closed interval started at -5 and it ended at 6. So what we did in order to find an absolute max or min is we went ahead and created a table. The table of values always starts with the endpoints. So that's what we started with as a group, was we started with the endpoints. The next thing we talked about is, well, where are some other critical points? Well, there are definitely critical points at -4 where we have a minimum, and at +2 where we have a maximum. So we're going to add -4 and we're going to add 2 to this table. So from there, all you need to do is take a look at the graph and find out what are the heights at the given values. At -5, we guessed the height was -1. At -4, we said the height was -2. At 2, we said the height was 4. And at 6, we said it was -7. So just looking at the table, we can say that the absolute maximum value is going to be this one here, 2, +4, because it's at the highest place on the y-axis. The absolute minimum is going to be the place where I go lowest on the y-axis, which is going to be this value right here, 6, -7. Okay, so let's keep it moving. Let's go to the next example. I need to get my mouse. Oh, there we go. Okay. All right. Next one. I know it looks crazy. This function is, the only reason it looks crazy is because it's a trig function. But we're given a function e to the x cosine of x, and we want to find the absolute minimum. So when I see this word absolute minimum, it's kind of like a ding, 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 like a light bulb moment where I should think, I need to make a table. Because to find an absolute minimum, I need to not only check critical values, but I also need to check endpoints. So I'm going to do that. First thing I'm going to do is identify the endpoints. Well, it says I'm on an interval between 0 and 2 pi. So I'm going to put 0 and I'm going to put 2 pi onto my table. From there, I need to identify critical points. Now, critical points happen when the derivative is equal to 0 and when the derivative is undefined. So I'm going to take the derivative first. And to take this derivative here, we are going to have to use chain rule. We have to use product rule. So the reason we're using product rule is because we're multiplying e to the x times cosine of x. Okay? So let's go ahead and use product rule. So product rule says derivative of the first times the second plus the first times the derivative of the second. So the derivative of e is so easy. That's why it starts with an e, is e to the x. Times the second is just cosine. Plus the first, which is e, times the derivative of the second. The derivative of sine of x of cosine of x is -sine of x. We're going to set this derivative equal to 0 and solve. And now this is no longer a calculus problem. Right now we have on our hands an algebra problem. We need to find out what values cause this function to equal 0. So maybe a little bit of trig is in there too. Notice how there's a common factor of e to the x. So I'm going to pull e to the x out, leaving me with cosine of x minus sine of x on the inside. Using the zero product property, I can set both pieces equal to 0. E to the x is equal to 0, and we can say that cosine of x minus sine of x is equal to 0. Now, e to the x cannot ever equal 0. If we take a look at the graph of e to the x is an exponential graph, and it does not equal 0 ever because it has an asymptote that approaches 0 from the left. So that's never. But cosine of x minus sine of x, that can equal 0. We have to use some trig skills to figure it out. In fact, this one is a little bit tricky. In order to find this out, I'm actually going to move the sine x over so that I have cosine of x is equal to sine of x. So I need to know my unit circle. I just do. So I want to know, when does cosine of x, at what angle does cosine of x equal sine of x? Well, you should have your unit circle in your brain, but if you need a little bit of help, maybe we should just draw a little bit of a unit circle. So I'm going to draw a little tiny unit circle up here. What I'm looking for is, when does the x value on the unit circle equal the y value? Well, I know that at pi over 4, I have the ordered pair radical 2 over 2, comma, radical 2 over 2. So pi over 4 has the same sine value as it does a cosine value. Remember, sine and cosine, sine is y value, cosine is x value. I also have the same value for x and y here at 5 pi over 4. 5 pi over 4 has an ordered pair of negative radical 2 over 2, comma, radical 2 over 2. And so we can say that the two critical values that I have here are pi over 4 and 5 pi over 4. So to find the absolute extrema here, I just need to plug all of these values back into the original and see which one's biggest. So once again, this is just algebra. So if you plug all of them in, the question is, which one's the absolute minimum? Well, the one that's the smallest has got to be the one that has a negative in it, which is this one. And so this right here, e to the 5 pi over 4 times negative radical 2 over 2 is the answer. I know it looks crazy, but it clearly has to be the lowest because it's negative. Everything else is positive. All right, let's keep it moving. All right, we're almost done. I think this is how the AP, I actually do want to talk about this. All right, so this is how the AP graders are going to grade your answer. And so what's so awesome about this question and many questions on the AP test is this. If you even just write f prime of x is equal to 0, that is a whole point on the AP test. That is amazing. There's only 9 points per question, and one of them is literally just saying f prime of x is equal to 0. You don't even necessarily have to get the derivative right, as long as you write f prime of x is equal to 0. Hopefully your derivative is right, but if you happen to be bad at derivatives, you actually can still get at least 1 point on this question by just stating that the derivative must equal 0. In fact, anytime you're given a question where they're asking about maxes and mins, they're asking about extrema, they're asking about changing from increasing to decreasing, you should think, I need to set the derivative equal to 0 and solve. Okay? So that is a whole point on the AP test. The next thing that you get points for is identifying pi over 4 and 5 pi over 4 as an answer. That's a whole point. And the last point is just answer with justification. And that's it. Your justification actually is your table. So you don't need to write too much. You can really just say, looking at the table, this one is clearly the lowest. All right, let's keep moving. All right, next one. It says the rate at which Sarah's AP daily videos generate likes is modeled by a function L, where L of t is measured in thousands of likes per day and t is measured in days since the videos were posted. And we know it's between 0 and 35 t. The derivative of L is given by this function. At what time between 0 and 35 is L of t a maximum? Okay, well, we could use the idea of absolute maxes for this one, or you could just use the first derivative test. So I'm actually going to just focus on the first derivative test here. The first derivative test basically shows me, when does my function go from increasing to decreasing or decreasing to increasing? When a function goes from increasing to decreasing, it is implied that the original function gets a max. And if I go from decreasing to increasing, it's implied the original function should have a minimum. So what I want to do here is, because I'm already given the derivative function, we actually graphed it on our calculator, and we came up with some values that would make the derivative equal to 0. So once again, if this was a free response question, I would literally write anywhere L prime of t is equal to 0. If I can do that, that's probably a whole point on the AP test, which is amazing. Okay, so on my calculator, we went ahead and took a look. When does L prime of t equal 0? When does this derivative sine of pi t over 30 equal 0? And we got that it equaled 0 here at 30. From there, we plugged in some values between 30 and 0, and we saw that the values were positive. Between values between 30 and 35, we saw were negative. In fact, we actually saw it on our graph. We saw the graph of the derivative, which we were graphing, was above the x-axis, and after 30, it was below. So if I'm going from increasing to decreasing, there must be a maximum there. So we can go ahead and determine that 30 is in fact going to be the maximum in this problem. Okay, so 30 must be the maximum. We actually can't evaluate exactly what 0 and 35 would be, but they can't be maximums unless the function happened to be not continuous. All right, I think we might have one more question. Yep, last question. This is a good one. All right, so for this last question here, it says the graph of y is equal to g prime. This is so important. This is the derivative graph. And it even says it twice here, derivative, is shown above between 0 and 5. At what value does g have an absolute min? Okay, to find an absolute minimum, I need to look for some key things. For absolute mins, I always need to check endpoints. Okay, so I'm going to make my table. The endpoints that I have are at x is equal to 0 and x is equal to 5. I also need to check critical values. So remember that critical values, once again, are where g prime of x is equal to 0. I'm going to write that just in case there's a possibility that I'll get points here. Okay, g prime of x is equal to 0. Well, there's no place where the derivative graph equals 0. It doesn't cross the x-axis at all. In fact, we can see there is neither a relative min nor a relative max here because there is no place where the derivative crosses the x-axis. So if the derivative goes from below the x-axis to above the x-axis, that means it's going from decreasing to increasing, which would make a minimum. We don't have that here. So the only options for us is to check the endpoints. So all I'm going to do is check the endpoints. Well, that's kind of hard to do because I don't have the original function. So here's what I'm going to have to do. I'm going to have to estimate what I think the original function looks like, and that's what I did over here. Doesn't have to be perfect, I'm just going to estimate it. Notice here how g prime of x is always greater than 0. I know this because it's always above the x-axis. If g prime of x is always greater than 0, then we know that f of x is always increasing. In fact, we stated this here. This is part of our justification. So because f prime of x is greater than 0, f of x is always increasing, which means my graph can be whatever I want as long as it's always increasing. Well, if my graph is always increasing, that means every point after the next point has to be higher because it's increasing, which means that the minimum value, if there is no relative min, has to be the starting point at 0 because after 0, I'm only getting bigger values. And so the answer is going to be that f of x is going to have its lowest value at the starting point, which is x equals 0. And it's because the function is always increasing. Okay, that's pretty much what we covered in class today. If you have any questions, feel free to send me an email and I would love to help you. Thanks, and I hope you have an awesome weekend.